We're looking at polymerization of esters, or actually how we make a polyester. You don't actually start with the ester to make a polymer that is called a polyester, you start with other things. So polyesters are commonly used in fabric. You're wearing polyesters now as part of the shirts that you're wearing. How do we make them? Well, they're called a condensation polymer. That implies that what molecule is released when they actually are formed?
Water.
Fantastic, water. There are two main types of condensation polymers that you learn about this year: polyesters and polyamides. They both release water or HCl, because you can use an acid chloride instead of a carboxylic acid to make these. We're going to focus on polyesters today as part of our learning about esters. And so we're going to first of all look at what we think the monomer or monomers must have as their functional groups. So what functional group must be present for us to create an ester of any sort?
Ester.
Any ester. What must it have? What functional groups must we have for an ester? Okay, so carboxylic acid. Or an acyl chloride, plus what else do we need?
And alcohol.
Alcohol, great. Most commonly, polyesters are made from two different monomers that join together to make the polyester. So I'm going to use the carboxylic acid and the alcohol rather than the acyl chloride version, but you can substitute the OH of the alcohol for Cl, which will help with that. So if we've got two different monomers, what you'll find is that it has the functional group on each side. So for example, here's one possible monomer. You'll notice that it's got the carboxylic acid group on both sides. You don't need to know its name. It's something like terephthalic acid, and I'm probably wrong with that. It's something like that. You don't need to be able to name them when they're like this, something that you've never met before. But notice that it's got the functional group on both sides. This means there must be another monomer which has got which functional group on both sides of it?
An alcohol.
Good, an alcohol. So let's join it with, for argument's sake, now this one I would expect you to be able to name. It's got 4 carbons and it's got an alcohol group on both ends. So because it's 4 carbons, it's going to be a butane something. So you've got butanediol, but we need to put the numbers in there as well. So at both ends, what will the two numbers be? 1, 4. This one you would have to name because it's the sort of thing you've met before. Okay, so 1,4-butanediol. You'd need to be able to do that. So what happens is you have n amount of these. N just means huge number, thousands and thousands of them, plus n of those, again thousands and thousands of those, in a 1-to-1 ratio. And they end up joining to look something like this. Okay, so this is what we call, actually have I got that correct? Yeah, this is our repeating unit. So this is going to carry on over and over and over again, where these squiggly lines are. So we can put a square bracket around it and a little n next to that as well, to say that that unit is going to be repeated over and over. What else has been produced? Hence its name, condensate water. So don't forget, it's plus NH2O. So you've got that being produced as well. Can we see why it's called a polyester? Can you see where the ester functional group is in this polymer? Stop me when I get to it. Stop. Good. We've actually got one here and one here as well. It's just that it carries on. Okay, so very good. You can see there's an ester group here, and actually it's not quite shown there that you've got an ester group on each end as well. So you've got the ester group is what holds the polymer together. Alright? So that's how two different monomers can be combined to make an ester. This would be a type of fabric. Okay, so when you see polyesters with particular names and numbers and your little tags for your clothes, that's a particular one of these. What I want to go through now is what happens if you get an acid on your polyester fabric or your polyester carpet or whatever, what actually happens to it. Alright, so I'm going to use this example because it's a nice easy one to do. So I'll draw that up again. Okay, if I was to react this with acid, then what do acids do to an ester? What will an acid do to an ester? We used this word yesterday or the day before. Hydrolyze it, so hydrolysis. So it's going to break the ester bonds up. So it's going to turn them back into the monomers that we started with. Under acidic conditions, it does exactly that. It is as the acid. So you're just going back to the monomers. So you put your OH on there from water, as it were. And you put your H from the H plus on either side of that. Okay, and again it's lots and lots of them, but I'm not going to worry about the details there. If you get a base, so sodium hydroxide for example, which is found in oven cleaner, if you get a base on your clothing, that'll also hydrolyze them, but it gives a slightly different product. So we'll do that one down here. The alcohol will still be the same because alcohols are neutral, so it doesn't matter if you hydrolyze with acid or with base, you're still going to get the alcohol. So I can copy that in again. But this is going to be slightly different. What is going to be different about it? It's going to be an ion. Good. So it's going to be the conjugate base. It's not going to be the acid. So it's got a 2- charge. Okay.